All right, to end this year, the last section that we're going to talk about is going to be trig and area. So we're going to use trig to find the area, which is kind of cool because trig was in the first unit that we learned and area is our last unit. So let's say we have a triangle here, ABC. We have the height kind of drawn, labeled as H there. Remember, it's perpendicular with our base B, and then you have the other sides A and C. And as we know, the area of any triangle is 1/2 base times height. But what if we only know the side lengths and we're not given the height? We're going to look at this triangle and we're going to be able to kind of use trig to replace H with the side lengths. So if I focus on that little triangle to the left, the sine of A would equal opposite over hypotenuse, so H over C. And if I isolate C, meaning I multiply C, or isolate H, so I multiply C on both sides, I'm left with H being equal to C times the sine of A. So we're going to replace that into this equation, and we end up with the area of a triangle equaling 1/2 times side length B times side length C times times the sine of A. And that we could use for any triangle. And what's nice about this formula is we can measure an angle and we can also measure two side lengths, and we can find any area of any triangle from there without knowing the height, the perpendicular height. So in number 1, we have this triangle here. We want to find the area of this triangle. So using this formula, this might seem a little bit weird because we have like B, C, and sine of A, and we don't really have any of that labeled. So another way that you could look at this formula is 1/2 times your side times the sine of that inside angle. So all these will kind of look like SAS2 as well when we did proofs. So we're going to do 1/2 times 21 times 12 times the sine of 48. Plug that all into your calculator, and you want to make sure you're in degree mode, and you'll end up with 93.64 centimeters squared. So another situation, we want to remember that the base and height are always perpendicular. So if we have two side lengths that are perpendicular to one another, aka we got a right triangle, we could just use 1/2 times the base and height. So in example number 2, we want to find the area of this triangle. I'm given a side length of 5, a side length of 13. If I know that missing side, I have my two perpendicular legs, and I could do 1/2 times side times side. What's also nice about this triangle is that it's a Pythagorean triple. So I'd see 5, 12, 13. So to find the area of this triangle, I could just do 1/2 times 5 times 12, and I'd have my answer.